Performing ISI's routing operations. See, yesterday I was telling you in NetID, there are many portions. For example, 47.0010. This is what I put as area ID. And then we have 6 bytes of system ID. One. For the first computer, I may give this as the system ID. But in yesterday's example, I put 1111 on the first router. Second router, I put 22222. Right? This is how many bytes? 1, 2, 3, 4, 5, 6 bytes. 6 bytes of system ID. And then we have N selector. That is of 1 byte. And that N selector will be always 0, 0. Now, if you see, count and see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 byte only I have used. But you can go up to 20 bytes. In that 20 bytes, this is 6 plus 1, 7 you leave. System ID and N selector. Rest all are area. That is why one of you asked me question, how big the area ID can. I said it can go up to 13. 13 plus 7 is what? 20. That's why I said 13 bytes. Your area ID can go from 1 byte to 13 byte. This says private area. In that private area, 10 is this area ID. Anyway, this is also area portion. To represent area, this 47 is not so important. Even if you don't put this, it is okay. Okay, so area ID can be 1 byte. It can go up to another 13 bytes. But system ID is always 6 byte. N selector, what is N selector? 0, 0 always. Why? Because this is IP version of ISIS. IP version of ISIS will have network selector 0, 0. 0, 0 means IPv4 ISIS. So இந்த ஏரியா போர்ஷன் தான் நீங்க வந்து எவ்வளவு நாளா வச்சுக்கலாம். மீதி இருக்கிற அத்தனை பைட்டும் இந்த 20 பைட்ல 7 பைட்டு தான் நீங்க இதுக்கு ஃபிக்ஸ் பண்ணியிருக்கிறீங்க. மீதி இருக்கிற 13 பைட் ஏரியாவை குறிப்பிட்டிருது தான். அது 1 பைட்னா வச்சுக்கோங்க, இல்லை 10 பைட்னா வச்சுக்கோங்க. யூ கேன் கோ அப் டு 13 பைட்ஸ். Alright. OSI layer address is implemented with NSAP address. See, ISIS is even before OSI. So, to adapt that ISIS to support OSI network layer, we have this NSAP address. NSAP address is to identify a system, a router in the OSI network. An address represents entire node. So this ID, net ID, which is called NSAP, but I use net ID. The reason is this is the command that we type to create NSAP address. This is what called as NSAP address. The whole thing, this 20 byte. This 20 byte we create by using the command network entity title, net, NET. So I use the word net ID, which is nothing but NSAP address. So for each ISI is running device, there should be one NSAP address. It's not per interface, it's per device. Various NSAP formats are used in various systems because different protocol may use different representation of NSAP. NSAP address or maximum of 20 bytes. So you have very flexible NSAP. The 20 byte higher order identifies the inter-area structure. Lower order identifies the system within an area. The system within this 10 area. So higher order area inter-area பத்தி குறிக்குது. Lower order bits system அந்த ஏரியாக்குள்ள இருக்கிற சிஸ்டத்தை குறிக்குது. First system. Yesterday I put example, right? 2222. That is another system in area 10. Any question this page? Any question in this page? No questions? Okay. See, this is what we just saw. 20 byte is area ID. இந்த segregationலாம் waste இதெல்லாம் பார்க்காதீங்க. இதெல்லாம் பல காலத்தில் யூஸ் பண்ணிட்டு இருக்கோம் தனித்தனியாக பிரிச்சு இப்போ அதுதான் இல்லை. So your area address can be from 1 to 13 bytes. 1 byte is what? 8 bit no octet. 13 byteங்கிறது தான் octet னு எழுதுறான். எல்லாம் ஒன்று தான். It can be from 1 to 13. It is composed of higher order NSAP octet. Higher order 13 bit byte தான் address குறிக்குது. 13 octet. System ID is a fixed length. How many bytes? 6 bytes. And then N selector is only 1 byte. And it is always 00. N selector. Service identifier, IPv4 service. IPv4 service ku 00. Right. Now this net ID or NSAP address minimum 6 byte. Eppadi area dot system ID NSAP means nselect, net select, nselect. That's it. How many bytes you have? 1, 2, 3, 4, 5, 6, 7, 8. This is the minimum. This is கம்மியா போக முடியாது. You can't go less than this. This is system ID, 6 byte. N selector 1. And area, at least you should have 1 byte. That's minimum. You can go up to 20 bytes. That's the maximum. Depending on the application that you develop, you may use different size. But for routing and switching, guys, 1 byte is enough to identify area. 1 byte itself is what? 256. 0 to 256 decimal values you can have. I can have area 200, I can have area 50, I can area 10, area 1. 8 bit 256 probabilities இருக்கு இல்லையா? To identify area, I need only just 1 or 2 digit number, maximum 3 digit number. Too much. அதுக்கு மேல போகுது. But this ISIS is not only used as a routing protocol in layer 3, it is also used in different concepts like layer 2, fabric path, VXLAN, underlay, and so on. So there they may use more than 8. All right. Okay. I wrote 47, it is not 47, 49. 49 is to say it's locally administered ISIS. In another word, it is IGP. It's not between autonomous system, it is within. Actually, ISIs we don't use between autonomous, we have BGP for that. அதனால தான் இதுக்கு ஒரு பெரிய முக்கியத்துவம் கிடையாது. 49 போட்டா என்ன போடணும். ISIஸ்னாலே ஒரு IGP protocol தான். It is an IGP protocol. You no need to say it is IGP by putting 49. Not only that, you can have your own number. நான் இது 47 போட்டேன், அது எடுத்துக்கிச்சு இல்லையா? It doesn't matter. It can be any number. Even if you don't give that number, it is okay. But area ID you need to have minimum of 1 octet. System ID 6-bit. N selector always 0 for IPv4 router. See this example. This is area 1. So you put 1 here. Now how many bytes you are using for area? 3 bytes. This is 1 byte, this is another byte, this is another byte. 3 bytes. Hexadecimal, 3 bytes. And 6 byte of system ID. See, unique router 1 க்கு 1111 கொடுத்துருக்காங்க. இது 0C2222 கொடுத்துருக்காங்க. For this 88888 99999. But this one is area 4, whereas this one is area 1. Right? So this is unique. It should be unique. The area address uniquely identifies the routing area and system ID for each node. All router within an area must have same area address. So this portion is same. The end system பத்தி கவலைப்பட வேண்டியதில்லை. End systemகள் computer. ஸோ அதை பற்றி கவலைப்பட வேண்டியதில்லை. அதுக்கெல்லாம் இப்போலாம் வந்து ESN நம்ம ISIS ப்ரோட்டோக்காலில் கன்சிடர் பண்ணுறது இல்லை. அதை விட்டுருங்க. கம்ப்யூட்டர்ஸ்க்கும் ISIஸ்க்கும் என்ன சம்மந்தம்? முன்னால் சம்மந்தப்படுத்தினாங்க. இப்போ நெக்ஸ்ட், ஏரியா அட்ரஸ் இஸ் யூஸ்ட் in a L2 routing. Yes. See, here it is L2 routing. It will use the area ID to route. But within an area, routing is based on system ID. ஏன்னா ஏரியா ஐடி காமனாக இருக்கு இல்லையா, அதை வச்சு ரவுட் பண்ண முடியாது. சிஸ்டம் ஐடியை பேஸ் பண்ணி எந்த வழியாக போனால் இந்த சிஸ்டம் ஐடிக்கு ஷார்ட்டஸ்ட், which route is shortest for this system ID. So it uses system ID to find the best path within an area. To find the best path between areas, it compares the area ID in the link state advertisement. Area ID is used in L2 routing. Any question in this page? Okay. Now, this is how you can use, even yesterday I was telling you when I was doing lab, it should be 6 byte. So you can use MAC address in this place. MAC address is also 6 byte, right? 48 bit, 6 byte. Or you can take one IP address, 192.168.1. Put remaining zeros in the middle. You are just making that 32 bit to appear like a 48 bit. It's just an ID, no? So you may use a MAC address of a router's interface as a system ID, or you can also use an IP address on the router as a system ID, or என்ன மாதிரி சும்மா 11112222233333 கூட போட்டு பண்ணலாம். Okay. System ID in the address is used to identify intermediate system router. It is not just an interface, it is the entire router. Cisco supports only 6 byte of system ID. வேற வென்ட்ரலும் நம்ம செக் பண்ணணும். Next, system ID is used in L1, level 1 routing. System ID is used in level 1 routing only. In area ID, எல்லா routerலயும் common இருக்கும். You are seeing here, it's common. I said the same thing on the previous page. So based on the system ID difference only, it will know this is coming from R3 and that is coming from R2 and this is coming from R1. System ID has a unique within system ID has to be unique within L2 router that forms routing domain. So so every router should have a unique ID. So not only in L1, even in L2 it should be unique. General recommendation, use domain wide unique system ID. So எல்லா routerலையும் within an area, between area, make sure that every router is got unique. Don't duplicate, don't have different duplicate system ID. Area ID தான் வேற வேற இருக்க போகுது. ஒரு ஏரியாக்கும் இன்னொரு ஏரியாக்கும் ஏரியா ஐடி தான் வேற வேற இருக்க போகுது இல்லையா? நம்ம ஏன் வந்து இதையே இங்கேயும் கொடுக்கக்கூடாது அப்படின்னு செய்யாதீங்க. அந்த கஞ்சத்தனம் வேண்டாம் அப்படிங்கிறாங்க. Make sure the system ID is unique. Even though area ID is different, still you keep the system ID also different. So, OSI addressing net address. N-selector address includes N-select field, processor, port number. Net NSAP within N-select field of 0. Refer to the device. What you need to know is the last digit, the last one octet should be 00 to identify IP version of ISIS, that is to fit inside OSI. Okay, so it's talking about 00. Now, sorry. So they're using 01 here. Let's see why they're using 01. NSAP is equivalent to layer 2 address, for example, virtual circuit ID. In frame relay, we use something called DELC number. DELC stands for data link connection identifier. So instead of MAC address, we used to use this DELC number to identify the frame relay circuit. Same way, this net ID, which is also called as NSAP address. What is, sorry, SNPA address. எங்கேருந்து வந்துருந்ததில்ல NSAP சொல்லிட்டு இருக்கிறேன். NSAP முன்னால இருந்துச்சுல்ல? Okay, இது NSAP. Okay, so this SNPA is nothing but the system ID வச்சு MAC address டிலே பண்றது. ஏன் இது இங்க கொண்டு வரான்? சரி. SNPA is equal to layer 2 address. For example, MAC address on the LAN. Interface uniquely identify a circuit ID. On point-to-point interface, SNPA is used. On LAN, circuit ID connected to 6-octet system ID of designated intermediate system to form 7-octet LAN ID. Okay, I got it. Sorry, do not compare this one with this. Do not compare this one with that. This is the one which it will show you when you check show ISIS neighbor. I showed you in the previous class to identify the designated router. In the lab I showed you. It was showing R2 colon 01. I was saying R2 is the DR. You know? So Cisco router don't use the system ID .01. It uses the host name of the router .01. 01 is auto-generated. 01 is to identify one LAN segment. This is one LAN segment for this router. When we do the lab next time, we will check this thing in more deeper way. Now let's go next. Level 1, level 2, and level 1, level 2, level 1 and level 2 router. I think we have seen this thing in the yesterday's lab, but still I would like to explain one more time. If the router is not connecting to another area, we make it as L1. L1 will form neighbor with another L1 and receive all the local networks of that area. That's why we call it as what? Intra area, within the area. ISIS maintains only two database, one for L1, another for L2. L1 local area information will be under L1 database, LSDB. All other area routes will be under L2 database. Level 2 is inter area. By default, we will have both L1 and L2. Those routers will have a separate database of L1 and separate database of L2. If router is only L2, then it won't have L1 database. If router is only L1, it won't have L2 database. Only L1 database will be seen. So this L1, L2 router has got information of both local area as well as other area, intra area as well as inter area. That is why they just compare it to ABR. Have you seen ABR database? You will have two database. Net LSA for area 0, net LSA for area 10. I've showed you one of the lab. When you go and type show IP OSP of database, you had net LSA type 1 for area 0 and for another area in the same router. Likewise, when you go to L1, L2 router, you will find a separate column for L1 and separate column for L2. L1 database, L2, level 2 database. Area address is used to route between areas. We already saw this. Between areas, it won't see system ID. It will see area ID. Because area ID is different, it finds the shortest path according to area ID. Whereas within the area ID will be same. So it cannot route, it cannot consider area ID. It only see the system ID in order to find the shortest path to reach those systems within the area. OSI, ISI's routing logic. Level 1 routers. For a destination address, it compares the area address. Sorry. Level 1 routers. For a destination address, okay. For a destination address, it compares the area address. If it is same, then it will compare only the system ID and find the route. It will only use the system ID to find the route, because when the area ID is same, definitely the packet is not of other area. You have to have the system ID, which is the tiebreaker, because the area ID is same. The பேசின விஷயம் தான் நேற்று போன ஸ்லைட்லயும் முன்னால ஸ்லைட்லயும் இப்பதான் பேசி முடிச்சோம். In L1 router, ஒரு டெஸ்டினேஷன் போறதுக்கு கம்பேர் பண்றீங்க. அந்த டெஸ்டினேஷன் சேம் ஏரியாவில் இருக்கிற மாதிரி டேட்டா பேஸ் காமிக்குது அப்படின்னா சிஸ்டம் ஐடியா பேஸ் பண்ணி தான் ரூட் பண்ணும். ஒருவேளை அந்த ஏரியா ஐடி டெஸ்டினேஷனோட ஏரியா ஐடி இந்த ரவுட்டரோட ஏரியா ஐடியும் வேற இருந்துச்சுன்னா பக்கத்தில் இருக்கிற L1 L2 ரவுட்டருக்கு அனுப்பிச்சு வச்சிடும். Why? Only L1 L2 router knows other areas. Just L1 router won't know other area information. So if area ID is not equal, what does that mean? The packet belongs to another area. Who knows another area information? Only an L1 L2 router. L1 L2 only knows both local and other area. So this is like a ABR router. This is like a border router for an area, right? Now, L1 L2 router. For a destination, it compares the area address to this area. If not equal, then it will use only the L2 database to route to that area. If it is equal, the L1 L2, அப்போ L1 database பார்க்கும். ஏன்னா area is equal. புரிஞ்சிச்சு, அதுக்கு சேம் ஏரியாவில் தான் நம்ம இருக்கிறோன்னு. ஸோ L1 database பார்த்து அதில் சிஸ்டம் ஐடி வேரியேஷனை வச்சு எங்கே இருக்குன்னு கண்டுபிடிச்சி அனுப்பி வச்சிடும். Based on the system ID, it finds the location of the destination. So you need only these two databases. You don't have too many LSA types like what you used to have in OSP. Just two databases, L1, L2. That's it. Identify systems. Example, OSI address in networks. So if I am pinging from here to here, definitely the area ID is different, right? So L1 router will just forward the packet to L1 L2 router. L2 router will check the L2 database because the source area ID and the destination area ID are not same. So it checks only the L2 database and forwards the packet here. This guy will compare and understands that it needs to go here by checking the system ID. It delivers the packet here using L1. ஏன்னா இவங்கிட்ட அனுப்பிச்சாச்சு, உள்ள வந்துடுச்சு, இந்த ஏரியாக்குள்ள வந்துச்சு, இது ஒரு ஏரியா. ஒரு சிஸ்டம் ஐடி பேஸ் பண்ணி இங்க அனுப்பிச்சு விட்டுரும். Okay. What is the default metric on a link? Anyone answer? What is the default metric on link? 10. But here in this example, they have configured different metrics. See, for some link they put 15. Those are modified, not default. They are configured, modified. Now, based on what I said in the previous page, tell me why it is going this way to reach y, why the path of x to reach y is this way, and the return path from y to reach x is this way. Why? See, from x to y, here it is 10, 20, 30, 15 is 45. All other routes are costly, you see. 10, 10, 20, 30, 40, 50. Whereas this path is 45. If it takes this path, then it is 10, 10, 20, plus 30 is 50, another 10 is 60, too costly. So going from x to y, this is the cheapest. Now the return traffic, you have two L1, L2. If it is other area, see the traffic needs to come to different area from area 2. If it is other area, where it will forward first? It will forward to the nearest L1, L2. Is this nearest or this one is nearest? Of course this is nearest. It is sending to this guy. If it has come here, from here which one is cheaper? 10, 20, 30, 40. Whereas this way, 30, 40, 50. This is 50 if it comes this way from here. So it comes this way. என்னாச்சு இங்க முடிவு பண்ணுது இப்படி அனுப்புறதா இப்படி அனுப்புறதா இதுதான் கம்மி L1 L2 இங்க வந்து பின்னாடி பார்த்தா இப்படி போறத பெஸ்டா தோணுச்சு அதனால இப்படி வந்துச்சு clear right okay next route leaking. In the yesterday's lab, I hope you can recall when you have only L1, we were not able to see other area routes in the routing table. Do you remember? But we were able to ping the other areas. How? Default route. Now, if in case you want to see L2 route in L1, you can leak it. ஒருவேளை உங்களுக்கு L1லயே ஒரு பர்டிகுலர் ரவுட் அடுத்த ஏரியா ரூட்டை நான் பார்க்கணும் எனக்கு டிஃபால்ட் ரூட் பத்தாது L1 தான் எனக்கு வேணும் நான் L2 மாறத்துக்கு தயாரா இல்லை ஆனாலும் எனக்கு மற்ற ஏரியா ரூட் எனக்கு வேணும் I still want to see other area route but I do not want to change to L2 or L1 L2 I still want to continue as L1 at the same time I also want to see other area routes in such situation you can leak route. How to do it now I'll show you in next class. It's a simple redistribution only. I'll show you. But I'm telling you, there is an option called route leaking through which you can allow the L2 information inside L1. What is the advantage? Even though L1 router is going to have other area routes, you still don't maintain L2 database. You don't maintain L2 database. Right? You don't have this EES and all, so don't think about it. From here, I think we will see next class.